Welcome to question 2 of the trial preparation series, and we continue with the Eastern Cape question paper, trial question paper from 2015. Question 2.1 says, given the following arithmetic sequence, arithmetic is the same as linear. 2.1.1, determine the value of the 50th term. In questions like this, you don't want to waste too much time. So if it's an arithmetic sequence, we know that we're going to have a certain common difference. So we will have 14 and then 9 and then 4 right there, and then it continues. Our common difference is for T2 minus T1, which is 9 minus 14, which has to be -5, which is the same as 4 minus 9, which is the same as -5. We are going to say, we know that Tn is equal to A plus n minus 1 d. So we're looking for T50. So what is our A? So our A is 14, and we're looking for T50. So our n is 50. So that's 50 minus 1. Our common difference is -5, like that. So you're going to punch this in your calculator, and let me see what I get. I got -231. Please confirm this in the comments and see if it's correct. Right, so that's -231. So we have our 250. We did not have to do anything extra here because it's only 3 marks. So we have our 250 being equal to -231. Right, question 2.1.2, calculate the sum of the first 50 terms. Right, it's also 2 marks. No need to be a gymnast. So what we're going to have is Sn. I would like us to use a formula that just uses A plus L, where A is the first term and L is the last term, like that, right? So nothing complicated because we know the last term. The last term is the 50th term because they want us to find the sum of the first 50 terms. So we know what the first term is, which is 14, and then we know what the last term is, which we just got, right? So to get S50, we're going to say 50 over 2, and our A is 14, our L is -231, and punch this in your calculator and see if you get the same as I do. So after punching my calculator, I get -5425 as the sum of the first 50 terms. Question 2.2 says, the following represents the first 3 terms of an arithmetic sequence. So we have -24p squared. Calculate the values of p. We know that if we have an arithmetic sequence, -24p and p squared, we can find the common difference. So in other words, T2 minus T1 equals T3 minus T2, which is equal to the common difference, right? So this will help us to find what P is. So I'll just say this implies each other so that we don't have the D right there. Right, so in other words, we can come and say P minus into -24 equal P squared, T3 is P squared, minus P, which is T2. Therefore, this side will have P plus 24 equal P squared minus P. Now let's take the left hand side to the right hand side. So we'll have 0 being equal to P squared minus 2P, because this P will become negative, and now you will add it to this negative P. So P squared minus 2P minus 24. Right, let me rearrange this so that the 0 is on the right hand side. So this is the same as P squared minus 2P minus 24 being equal to 0. So we're looking for factors of 24 that when we multiply should give us -24, and when we add or subtract should give us -2. So I am thinking of -6 and +4. So -6 multiplied by +4 gives us -24. -6 plus 4 gives us -2, right? So we can come and say P minus 6P plus 4 should be equal to 0. And our P's, because they said calculate the values and the S's in brackets. So we can say P equal to 6 or P is equal to -4, just like that. Right, 2.3 says consider the geometric series 3 plus m plus da 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 right? So, and then they say 2.3.1, for which values of m will the series converge? It is important to note that a series only converges when our r is between -1 and 1 exclusively, right? It does not equal 1, but it should be exactly between -1 and 1. What is our r? In this case, our r is our common ratio. So how do we get common ratio in a geometric series? We get r by taking the second term and divide it by the first term. And our second term here is m divided by the first term, which is 3. So we come and say -1, because we now have our r, right? So this is our r, right? So -1 m divided by 3 and then 1. So we need to leave m alone. So in other words, we're going to multiply 3 everywhere. We're going to multiply by 3 everywhere so that we can cancel this right here. So this side we're going to have -3, m is now left alone, and then this side we're going to have 3. So this is the solution. So we've solved that m should be between -3 and +3 for our series to converge, right? So that was question 2.3.1. Question 2.3.2 says it is given that 3 plus that, so we are given the same series, but this series now adds up to 27/7. Each and every series, each and every geometric series that converges always sums to infinity. So in other words, to solve for 2.3.2, we are going to sum to infinity and say a divided by 1 minus r, like that. So we are told to calculate the value of m, right? So we are given the sum to infinity, which is 27/7. We know our a, and our r is m/3, and we are told to find m. So in other words, we can just come and say this is 27/7, and our a is 3, and that is the same as 1 minus m/3, like that, right? So there are multiple ways to solve this. So you can either cross multiply, in other words, take this denominator and multiply this numerator, and take this denominator and multiply 3, this numerator this side. So just do this on your own and see that we get the same answer. So what I'm going to do is I'm going to try and cross multiply. So I am going to take this and multiply 27, and I'm going to take 7 and multiply 3, like that. So we cross multiply. So in other words, we're going to say 27 multiplied by 1 minus m divided by 3, and we're also going to say 7 times 3, so that we have something linear like this. So in other words, we're going to have 27, I'm multiplying in like this. I'm going to have 27 minus 27 m divided by 3. Oh, I just realized that 27 divided by 3 is 9, so we can just say 9m, and 7 multiplied by 3, that's 21, right? So let's take 9m to the right hand side so that we cancel out the negative. So we're going to have 27 minus 21 this side, and then that side we're going to have 9m, like that. So 2 and 2 go, so that's 7 minus 1, which is 6, and then 9m. This will then be the same as m being equal to 6 divided by 9, which is the same as 2/3, because 6 divided by 3, that's 2, and 9 divided by 3, that's 3. So this is the same as 2/3. So if it doesn't make sense, again, you can comment down below and I'll get to it as soon as I can. 2.4 says, let's try to read the question first, because these are what we call level 4 type of questions, or higher order questions. They are not necessarily hard, but they are actually things that you cannot find in your textbook. So it's probably the last questions that you find on each and every question. So yeah. higher order questions or level 4 type questions should not scare you because they are not necessarily hard. They are just not familiar or with things that you've seen in your study guides or your textbook. So now let's see what we have, right? So they say the sum of the first 3 terms of a geometric sequence is 31.5. The sum of the 4th, 5th, and 6th term of the same sequence is 3 and 15/16. Determine the value of the common ratio R. Now, let's first deal with what we have. So, we are summing the first 3 terms of a geometric series. So, in a nutshell, we have first 3 terms are A, and we know that to get the second term in a geometric series, we are going to take the A and multiply by the common ratio. This is the second term. And in order to get the third term, we're going to take the second term and multiply by R, which is, the second term is AR. And we're also going to multiply it by R. So that's AR times R, which essentially is just A squared, right? So we're going to rewrite this. So we have our first term, our second term, and our third term, like that. So we are told that this equals 31.5, like that. So let me erase this. I don't really like working with a mixed fraction like this. I'd rather work with an improper fraction. How can we turn this into an improper fraction? Let's say A plus AR plus AR squared. To turn this into an improper fraction, you just take 2 and multiply 31, and the answer that you get, you add 1. So in other words, that's 2 by 31, that's 62. 62 plus 1 is 63. So this is the same as 63 divided by 2. So this improper fraction is better than working with that. I don't like working with mixed fractions. So that's the first information that we have. So, and then they say the sum of the 4th, 5th, and 6th. So if you were really paying attention with what we did in this one, so look at this. The first term, which is T1, only has A. The second term only has A and R. And look at the R. The R only has 1 as an exponent. So T2 has R to the power of 1. And then T3 has R to the power of 2. Can you see the pattern? So the A remains the same, but the R is only the term minus 1. So if you are having T3, that means it's going to be R squared. So in other words, if we are told that 4th and 5th and 6th term, we know that to get T4, T5, and T6, we know that we're going to have A, but T4 is going to be AR3 because we said it's the term minus 1. So AR3 plus AR4 plus AR5. So AR5 is term 6, AR4 is term 5, AR3 is term 4, according to what we saw, right? So let me erase this. I hope it made sense. If it doesn't, leave a comment down below, right? So we are told that this AR to the power 3, AR to the power 4, and AR to the power 5 is equal to 3 and 15/16. Again, let us convert this to an improper fraction. So we're going to have AR to the power of 3 plus, which is 3/16, like that. So let me take this newfound equation and place it closer to that equation we had in the first section of the question. So let me erase this. Right, so this is what we have. We have the first equation and we have this second equation. Right, there are 2 methods to solve this. There are 2 methods that I'm going to try to solve for R, because we're actually trying to solve for R. So the first method is we're going to first try solving by inspection. So what do I mean by solving by inspection? I mean that it is sometimes easier to solve for something by just looking at it without actually doing a lot of work, right? So if we look at what we have a lot of similarities. What do I mean by a lot of similarities? We have 63 here and 63 here, and we see that we have a lot of A's and R's, So we can manipulate our equations such that they look a bit similar, right? So in other words, here's what we can do. So we can try to manipulate all these two equations such that they look a little bit similar so that we don't have to work too hard, right? So before we solve by inspection though, let's try to rearrange these questions such that they look similar. So let me try and rearrange them this side. So this first equation, let's factor out A like that. So in other words, we're going to factor out A. So this side will be left with 1 plus R squared, and then we'll be left with 63 over 2. And I want us to be left with 63 only this side, right? So in other words, we're going to multiply this by 2 and this side by 2. So this is going to be the same as 2A, 1 plus R squared, being equal to 2 and 2 cancel, so we'll be left with just 63 like that. So I want us to take this equation and place it here. So we will have 2A, 1 plus R squared being equal to 63, right? So we're done with the first one. We're done rearranging the first one, right? So now let's rearrange the second one now and see how it looks like. Now the second one, we are trying to make it look like the first one that we rearranged, right? So in other words, we also need to leave 63 alone this side, and we need to find a way to leave 1 plus R squared in here. So to do that, we are going to factor out AR cubed like that. So if we factor AR cubed, this divided by that would be 1 plus AR to the power of 4 divided by AR to the power of 3 is going to be R, because A and A will go. So AR to the power of 4 divided by R to the power of 3 is just R, plus AR to the power of 5 divided by AR to the power of 3 is just AR squared. I hope you're seeing this. So, and then this side will be left with 63 divided by 16. So again, we want to leave 63 alone this side. So we're going to multiply everything by 16 and here by 16 like that. So in other words, finally we will have 16 AR cubed 1 plus R squared being equal to 63 like that, right? So we take this and come and place it this side and say 16 AR cubed 1 plus R squared being equal to 63, right? So now here's what solving by inspection does, right? We don't need to work very hard from here, because look at this. We see that these equations, they all equal to 63, which means we can equate them, but not necessarily, because if 63 is equal to 63 and this part is equal to this part, and we know that A is equal to A, right? So by inspection, we don't need to think that much, because all this left hand side should be equal to 63. So in other words, if A and A are equal and this stuff in bracket is equal to this stuff in bracket, whatever is left should be equal to each other, right? So in other words, 2 should be equal to 16R cubed. By inspection, we do not have to think that hard. So by inspection, we know that 2, this 2 right there, because it's the one that is left, should be equal to what is left on this other equation, so which is 16 and R cubed, right? So we are solving for R, so it's easy to solve for R in this case because it's just R now. So we're going to say 2 divided by 16 is equal to R cubed, which is the same as 1 over 8 R cubed. In other words, cube root and cube root this side, so r is going to be 1 over 2, right? So we did not have to work very hard. We just had to look at what we were given and then declare that if all these things are all equal to 63 and we have some factors that are equal to each other, we can declare that the remaining factors should be equal to each other. That's what solving by inspection is, right? So now let's try the second method where we're going to try solving by substitution. Let me erase some of the stuff that is in here. All right, so if we are going to solve by substitution, we need to make a few changes to the second equation. You see this equation? So I want us to leave the first equation alone. Let's just leave it like that. Now, I want us to make the second equation to be similar to the first equation. So what do I mean by that? As you can see, in the first equation, we have A, we have AR, and we have AR squared. So how can we make the second equation to be similar in this sense, right? So in other words, we can try to factor out r cubed, because in this case, we will only be left with a in the first term. So if we divide ar cubed by r cubed, we get a, and ar to the power 4 divided by r cubed, that's ar, and you can see the pattern, this is ar squared, which is now being equal to 63 divided by 16, right? So we have a plus ar plus ar squared, apologies, this is squared, being equal to 63 divided by 2, and we have r cubed, a plus ar squared, being equal to 63 divided by 16, right there. Right, so now let's try using substitution. Now look at this. You see this a plus ar squared is equal to 63 divided by 2, and we have the same ar squared down here. So in other words, where there is this expression, we can just substitute and put 63 over 2. Right, so we can take this and put it here because this equals to 63 over 2. So in other words, we can substitute whatever that is with 63 divided by 2 like this, and we're going to say 63 divided by 16 right here. So solving this, I know that you might want to try to solve it in using different ways, but I think you know by now that I really love cross multiplying. So in other words, I'm going to take this 2 and multiply 63, and I'm also going to take this 63 and multiply 16. But don't be in a rush because I see common things here, so I don't need to multiply right away. But what I can do is to show the multiplication and say I cross multiply 63 and multiply 2 and 16 multiply by 63, right? So I do not need to multiply right away because I saw that I can cancel out 63 like this, which leaves me with just 2 over 16, and we've been here before. So r cubed is the same as 1 over 8 because 2 goes once and it goes 8 times to 16, and cube root of that, this is the same as 1 over 2. So this is another method to do it. So you can either use inspection or you can either use substitution. It all leads to the same answer. So if you use another method here, you can, and you think it's cool, you can share it in the comments below, right? So I love cross multiplying, so I just cross multiplied. And if you don't understand how I cross multiplied, again, you can say it in the comments and I will re-explain. Right, so we've come to the end of question 2. I suggest that you take a break, drink some water, get a little bit of snack, and reflect on what we did. And be sure to come back for question 3, which is up next. I will see you in the next video.